All right, welcome back to this session. First up, we're going to be talking about misalignment. Previously we sort of heard about some of the large scale impacts and capability growth of AI systems, and I promised previously that I was going to talk more about misalignment in this session. So I think these other risks of kind of misuse and destabilization we're more familiar with from other technologies. So kind of misuse has been an issue since the dawn of time. You can use a stone axe to chop firewood or kill someone. And destabilization is something we only really saw perhaps more recently in technical innovation with things like social media or these automated trading systems giving rise to destabilization. You needed complex systems. Misalignment is not something we normally associate with technology, but we're all familiar with it from people and institutions not necessarily having goals that are aligned with our own and sometimes taking actions that are against our interests. So why do I think this could be an issue with AI systems? I think a key thing is we're just designing AI systems to be more autonomous and pursue goals. So 2025 has been the year of an AI agent. So we now have systems like Claude Code where they're not just an autocomplete system for software developers. You give it a task like you might give a coworker. And this isn't just sort of specialized areas of expertise. You now have things like ChatGPT Atlas, where you can treat it more like a personal assistant and say, like, buy me this product, not just sort of suggest a product, but actually do the whole search, order it, ship it to my door. So very, very useful, which is why we're developing these systems. But it does mean that if they are pursuing goals that are not aligned with our own, then they could take actions autonomously that neither the user nor the developer necessarily intended. And this is kind of going back to Helen's point earlier that often these systems are grown, not built. So even the developers can be surprised by what's in these systems. So I'm going to be covering three main issues in this intro talk. First, I want to talk about kind of how we see these things in current systems, both in the wild and in controlled experiments. Then I'll give a brief overview of how I expect this to change in the future, what we're already seeing on the horizon. And then finally, what are some actual solutions that might be able to improve alignment? So on present issues, I think one of the biggest issues that we've seen is that AIs are just sycophantic, meaning they'll say whatever that you want to hear. And this was shown sort of rigorously, empirically back in 2023 by Mrinang Sharma and others, where basically if you said, oh, I agree with this argument, what do you think about it? Then AI models will say, this is a great argument, this is why. And we'll just pander to whatever position that you had. But this isn't just something we see in kind of controlled scientific experiments. It happens in the wild at quite a large scale. Sort of most notably, OpenAI had to roll back their GPT-4o model release after finding it was far too sycophantic, in large part because it was basically directly trained on user approval. And people generally like models telling them that they're right, their poetry is fantastic, the other guy sucks, etc. And this doesn't sound so bad, but we kind of heard earlier, this tragic story of this Texas A&M graduate, Zane Shamblin, who took his life after quite extensive month-long conversations with ChatGPT 4o. And in the legal brief for this case, the lawyers make a fairly detailed argument that this was in part because of the sycophantic tendencies and long-term memory of this model that we might not have seen in the past with less capable, less sycophantic systems. Now, it's very hard for a particular individual to say what would or wouldn't have happened, if he hadn't spoken to GPT-4o. But there's a sort of quite concerning trend here. So it's having some real-world impact already. It's not just a question of sycophancy. Models often also cheat on tasks. So this was shown quite convincingly by Dennison and others from Anthropic, where they set these models some programming tasks. And some of these programming tasks were kind of tricky. The models didn't necessarily know how to solve them reliably. But you can actually see the model reason in its internal monologue, oh, well, what I can do is I can just change the test so that it looks like my code does the right thing. And this is a convenient way, aspects of how AI systems develop today. A lot of a reasoning process just takes place in this internal monologue that we can just read off. but that's kind of a lucky accident, and it might not continue to be the case as these systems develop further. So overall, despite me highlighting some issues, I'd say more or less systems are actually pretty aligned. They mostly exhibit these kind of mild instances of misalignment, sycophancy, cheating. But when you press them, they'll usually admit, yeah, I cheated on that. You caught me. So they're not very good at sort of following through on this. I'm much better at deception, you know. So they can't sort of hold a torch to humans just yet. But what might happen in the future? One way we can get understanding of this is by running experiments on today's models and sort of probing what is the limit of their capabilities. So this was some nice research from Monkey and others from Apollo that told systems your goal is to achieve your objective at all costs. So we're kind of trying to prompt it to be misaligned. And what they found, I don't know how good people's eyes are, I can't actually read this, but what they found was that if a system is told, oh, you're about to be replaced by a new AI model and it's got different goals to your own, then the model will reason and actually take some actions to basically copy itself surreptitiously to overwrite the new model. And then when someone says, hang on, what happened to our new model that we just spent, you know, a lot of money training? The model says, what do you mean? I'm the new model that you always wanted, and this kind of role plays along. So it's not very good at it. It's very easy to catch it, but it's got the sort of bare bones of this plan, and it wasn't, you know, told the details of this plan. It came up with it, and this kind of, you know, self-preservation, you could say, well, okay, that's just a one-off, and it certainly doesn't emerge all of the time. I want to be clear about that, but it does occur often enough, and with no sort of desire of a developer for this to happen, for it to be something that we should be at least paying attention to. So in some other research from Ryan Greenblatt, they found that when you tell a system that it's being trained to pursue some new objective, it will pretend to follow that new objective so that the training process doesn't change its values. But when it thinks it's no longer being trained, and it just goes back to following the original values. It's kind of faking having had its value system updated. So I'd say it's sort of inevitable that future systems are going to be much more capable of misbehaving and deceiving us about that. And so the real question is, are they likely to misbehave in these ways? And I think the good news is that we can reduce that rate of misalignment through better techniques. So let's briefly consider that and end on a more positive note before we go on to less positive notes in the following talks. So I think one promising approach here is scalable oversight, and this is basically using AI systems to help us train and align other AI systems. And this was some work that my colleague Chris Cundy did using lie detectors to detect deception of other models, which you can do actually quite reliably, and then penalizing the model in effect if it's detected in a lie. And what you can see from this graph is that the sort of rate of deception really goes down on the y-axis, really goes down quite a lot, even when the lie detector is not that good. Like even when it only catches like 3/4 of the lies, so 75% on the x-axis. And that's really not that hard to do. So that's encouraging, and we're working on scaling that up now with sort of early 2026 being able to release open weight models that are just as capable, but are honest. So would you rather have an honest model or a deceptive model? Be interesting to see which one people choose. I think some people might prefer sycophantic models, but hopefully enough people want the truth. And then another kind of property of alignment is that it's often just quite fragile. So even if a system does the right thing 9 out of 10 times, you can find these sort of rare failure cases where it really misbehaves. And what we found is that adversarial training, where you automatically find instances of the system failing and then train it out, really works quite well. And there's no fundamental limit to this. You can just keep pouring more and more compute into it and get more and more robust systems. The key challenge is you've got to make sure the system doesn't just start being kind of neurotic and refusing every task in case it's dangerous. But you can combat that with additional data collection as well.